So, hello everyone. My name is Siddharth Srivastava. My registration number is 21BCE5807. So, in this video, we will discuss about Nand2Tetris Project 3. In earlier videos, we discussed about Project 1 and 2. So now, today we are going to discuss about Project 3. So let's move further. So in this project, we will discuss the concept of sequential logical circuits, and we will focus on designing and implementing a memory chip called random access memory, or it is also called RAM. And this project builds upon the knowledge gained in the previous projects, where we learned about Boolean logic, combinational circuits, and hardware description language, also known as HDL. So let's move further. So our first topic is single bit register. So single bit register is a basic building block of digital circuits, and it is used to store a single binary value, either 0 or 1. It consists of logic gates that allow data to be stored, and we can also retrieve it. So it has two sides, input and output sides. From input side, we new values to be stored in the register is provided, and from output line, it reflects the current stored value. And there are also control signals, and this control signal determines whether the input value should be loaded into the register or not. When load value is high, the input value stored in the register. When load is low, the register retains its current value. So here is the diagram also of single bit register. It is a multiplexer, and this is the input side, and it is a D flip-flop in between, and we have output side also. And this is the timing diagram, as we can see in this graph. 1 represents high and 0 represents low. Okay, so let's move further. So now we come across 16-bit register. 16-bit register is a digital circuit component that is used to store and manipulate 16 binary values, zeros and ones only. It consists of multiple single-bit registers connected together to create a larger storage unit capable of holding 16 bits of information. From inputs, it starts from 0 and it is 0 till 15. So in total, there are 16 inputs. These are the input lines where the 16-bit values to be stored in the register is provided. And output, from the output side, it reflects the current stored value of the 16-bit register. So its functionality is, when load is high, the 16-bit register takes the values from the inlines and stores them. When load is low, the 16-bit register maintains current value, and the current stored value is available on the output lines. So here on my right side, it is the diagram of the 16-bit register. It is quite complex because it is using 16-bit registers, and various logic gates are also being used here. So let's move further. So now we come across RAM 8. RAM also stands for random access memory. RAM 8 chip is a component used to implement random access memory capable of storing 8 16-bit values. So that's where its name has been derived. So it allows reading and writing data to specific memory locations based on an address input. So from input side, this is the input line where the 16-bit value to be returned to the RAM is provided. And load, there is also a load line. This control signal determines whether the input value should be returned to the RAM or not. When the load is high, the input value is stored in the RAM at the specified address. When load is low, the RAM retains its current values. And there is address also, address bit also, address signal also. These are the address lines used to specify the memory location to read from or write to. The RAM 8 chip supports 8 memory locations, so there are 3 address lines: address 2, address 1, and address 0. Starting from 0 to till 2, it is there. And output lines we have from 0 to 15. So these are the output lines that provide the 16-bit value stored in the RAM at the specified address. So this is the block diagram of RAM 18 chip, and this is select 1 and select 2, read and write, and 7-bit address is there, and this is 8, the output is 8-bit data bus. We get output in the form of 8-bit data bus. Okay, so next we have very important topic, which is program counter, which is also known as PC. A program counter is a key component used to store and manage the address of the next instructions to be fetched and executed in a computer program. It keeps track of the current program execution point and determines the sequence of instructions to be executed. So it is the main function of program counter. So in inputs, we have, this is the input line where the 16-bit value representing the next program instructions address is provided. And increment, this control signal determines whether the program counter should be increment or not. When increment is high, the program counter increments to the next instruction address. When increment is low, the program counter remains at its current address. So, and output sides, these are the output lines that reflect the current program counter value, representing the address of the next instruction to be fetched and executed. So its basic functionality is, the program counter is essentially a register that stores the current program execution address. It is usually implemented as a sequential circuit with memory elements such as D flip-flop. And here we have its diagram also. It contains various buses also in it, and it also uses the multiplexer and stack parts. So this was about the theory part. So now we will move to implementation part now. So let's move to the hardware part. I'm sharing my screen. Just a second. So first we will implement single bit register. So I'm loading my chip here, and HDL file I have to select. This is the file I loaded. Now we have to load its equivalent TST file as we know. And this is single bit file. So we have moved the speed to fast, and now we will run it. It is a very big code, so it will take a little bit time. So we have reached the end of the script. So our compilation is successfully executed. Now let's see the output. See, this is the output. It's quite large. So we will now compare it. So while we are comparing, we see there is no changes in the output and the comparison. So which confirms that we are moving on the right track. So now let's move to 16-bit. Now let's implement 16-bit register. So we have to select register HDL file. and then register a TST file we have to load, and let's run it now. So these are big codes, so it is taking a lot of time to execute, but it should be run properly. So we have reached the end of the file. So let's check the output. So it is the output. And now let's check whether we are right or not by comparing the output. So there is no change in the comparison. So that means it is correct only. And now let's implement a program counter. So let me load the program counter. Here it is, pc.hdl. And now I will add tst file also in it. So we have reached the end of the code. Now let's see its output, and here it is. Here is the output. Now let's compare it. So there is no change in the comparison, so that means it is correct. Now let's implement RAM 8 finally. So RAM 8 HDL we have, and RAM 8 TST I will select here. Now let's run it. Taking time because it is lengthy code again. So we have reached the end of the code. So it has run successfully. Now let's check the output. So this is the output. This is the output. And now let's compare it. So no change in the comparison bit. So that means it is again it is correct. So these were all the implementations which we were to see in this project. So we have implemented all the simulation. All the discussed circuits in the HDL file. So thank you all to see my project, and I enjoyed doing this Nand2Tetris project very much. So thank you for everyone for seeing my video.